All right, welcome back to Chemistry Week 3. So this is Lesson 5 in Unit 9. On Friday, you'll have Lesson 6. We're still talking about solutions, molarity, that sort of stuff. Keep in mind that next week, that is Easter week, on Wednesday, Dowling is allegedly doing a sort of live online class day, so look for more information about that to come in the announcements page or from Mr. Maindring. So, with that said, let's talk about what we're going to talk about today. We're going to talk some more about molarity and solution concentrations. So molarity is the most important thing we're doing all unit. And this unit being possibly our last unit and certainly our most important online unit, right? We should spend some time on the most important thing in our most important unit. So molarity. We're going to focus on that today. We're going to do some more examples of molarity today. You're going to have a couple more practice problems with molarity today, and it'll all be great. So let's get into it. Remember our formulas here. All right, I suppose it's on this side. Formulas. Well, video making is hard. So molarity is moles of solute divided by liters of solution. That's the one we're talking about today, not to be confused with molality, which is moles of solute divided by kilograms of solvent. So molarity, keep that one in mind. Here is a new example for calculating some molarity stuff. I'm going to walk through this with you. So molarity is equal to moles divided by liters. All right, so moles of your solute divided by the liters of solution. And sometimes, right, you're just calculating molarity. It's like you have this many moles, this many liters, what's the molarity? Well, that's straightforward and important, but oftentimes you know the molarity and you need to calculate the moles or calculate the liters. So it's kind of like working backwards. It's all the same equation, but we're just using it in a different way. So I want to take some time today to focus on what it's like to do some molarity problems that don't involve actually calculating molarity, doing some problems where you're given molarity and you have to calculate moles or liters. So I'm going to walk you through an example of that right here. So if I had a question that said, what is the volume of a 0.008125 molar solution containing 1.55 grams of KBr? That could be a real problem. All right, you could actually be in the lab and you could actually have a vial that says molarity and you know how many grams of whatever you put in it. And you want to know, well, what's the volume without having to pour it out and lose some of it by pouring it out and all that? Well, you could do that. Here's how. First thing we got to do is look at what we have. All right, we have the molarity. It's right here. The capital M, that means molarity, right? We have grams, and that's it. So we have a molarity and we have a grams, and we're looking for a liters. Well, we need a moles. All right, and that's going to have to come from our grams, right? And now we've done lots of grams to moles throughout the year, and we're only going to keep doing more. So keep that in your mind. So here's what we do. We take 1.55 grams of KBr, because that's what's given to us, and we got to turn that into moles. Now, always, all right, always, when you go grams to moles, you're going to divide by the molar mass. So you open up your periodic table, or you Google it in these trying times of distance education, and you plug it all in on your calculator. You find that K, potassium, is 39.10 grams per mole, and Br, bromine, is 79.90 grams per mole. So you take 1.55 divided by those molar masses, and you get 0.013 moles of KBr. All right, so that gives us our moles, and we have molarity, and we're solving for liters. So now it's just Algebra 1, your favorite class you ever took. So molarity equals moles divided by liters. So 0.008125 equals 0.013 divided by x. Now you can rearrange the equation to solve for x. What you do, you multiply both sides by x, right? And then you divide both sides by 0.008125. It's cross multiply and divide, that sort of thing. So you'll end up with x equals 0.013 divided by 0.008125. All right, x goes up on the left, the 0.008 goes down on the right. All right, just like that. And when you plug that into your calculator, you'll get x equals 1.60. And since we're solving for liters, it's 1.60 liters. All right. So take some time to look at this example closely, right? Because The hardest part is just realizing how you have to rearrange the equation. And we've done lots of rearranging equations in chemistry this year, and you've done it in algebra before. Right? So you have the skills to do this. All right? You're capable, you can do it. It just takes an extra step of thought, which I believe that you can do. So with that in mind, let's take a look at some practice problems. So 3 problems here. How many grams of calcium chloride have been dissolved in 1 liter of a 0.1 molar solution of calcium chloride? Well, similar to last time, all right, we have molarity, and we have liters. So we need to calculate moles, then we can turn moles into grams. So it's 2 steps. Solve for moles, turn moles into grams. The second one here, what mass, which is to say how many grams, of sodium hydroxide is in a 0.25 liter of 3.0 molar sodium hydroxide? Well, we have moles, we have liters. Same thing, you got to solve, sorry, we have molarity and we have liters. You have to solve for moles and then convert moles to grams. Remember, to convert moles to grams, all right, you're going to take moles times the molar mass. Molar mass comes from the periodic table. Finally, what is the molarity of a solution containing 9.5 grams of NaOCl per liter? So you got this many grams, you have 1 liter, you're actually solving for molarity. So you're going to go grams to moles, moles divided by 1 liter gives you molarity. So pause your video, take some time to solve these problems. You know, solving them yourself and trying to get the correct answer is the best way to learn this stuff. You won't learn very much just by skipping ahead in the video and looking at the next slide. So take some time to take a look at these problems, and then I'll show you the answers. All right, here are the answers. I sort of set it up a little bit for you here in the answers to help you kind of understand where I'm coming from. So the first one, 0.10 molar equals x divided by 1 liter. So we're solving for x. Well, 0.1 equals x divided by 1. Well, that means 0.1 equals x, right? So we have x equals 0.1 moles, all right? Now we have to convert moles to grams. So we take 0.1 times the molar mass of calcium chloride, right, which you can find on the periodic table. So you take 0.1 times that molar mass, and you get 11.10 grams of CaCl2. Second, right, what mass of sodium hydroxide is in 0.25 liters of a 3 molar sodium hydroxide solution? Well, 3 molar equals x divided by 0.25 liters. So 3 times 0.25 equals x. X equals 0.75 moles. You can convert moles to grams by taking moles times the molar mass, right? So you get 0.75 moles times the molar mass of sodium hydroxide, 22.99 plus 16.00 plus 1.01, and you get an even 30.00 grams of sodium hydroxide. An even 30. All right. Finally, what's the molarity when you have this many grams per liter? Well, you take 9.5 grams divided by the molar mass of NaOCl, and then you divide it by 1, and there you go, 0.13 molar. Remember, molarity is molar. Capital M means molarity means molar. All right, so that's more molarity practice for you. All right, you're going to have 1 or 2 questions as a homework over molarity, which should give you some more time to practice molarity because that's the important stuff. Secondly, today, let's review a little more about diluting molar solutions. So, remember that if you have a volume of a solution and you know its molarity, you can then make it into another solution by changing the volume to get a new molarity or changing the molarity to get a new volume. So M1V1 equals M2V2. You'll need to remember this equation for the rest of your life, or at least through your freshman year of college when you have to take general chemistry and you do this. So M1V1 equals M2V2. So what volume of 2 molar calcium chloride would you use to make 0.5 liters of 0.3 molar calcium chloride? Well, very simply, M1 is 2 molar. What volume means V1 is our variable. 0.3 molar is M2. 0.5 liters is V2. 2 times X equals 0.3 times 0.5. Written out like this. Well, we can get V1 by itself by dividing both sides by 2 molar. All right, that's how you do it. You divide both sides by 2 molar, and you get V1 equals 0.3 molar times 0.5 liters divided by 2 molar. And then you can plug that into your calculator. The parentheses will help your calculator function. And when you plug all this stuff in, you get 0.075 liters, which we're using 2 decimals with everything because we're not doing sig fig. So you get 0.08 liters. Volume 1 is 0.08 liters. M1V1 equals M2V2. This is just algebra disguised as science. Chemistry and physics. It's just algebra and calculus disguised as a science class, and that's all that's happening here. You're just doing algebra. But instead of Johnny has 7 apples and he also has 37 candy bars and diabetes or whatever, right? You were doing it with molarity and liters and stuff. So take a look at as it's written out. Use this written out thing. Write it in your notebook or whatever scrap paper you have lying around your house and solve these practice problems. Again, they're just M1V1 equals M2V2. That's all they are. So look for the variable, plug the rest of the numbers in, and then solve for the variable. Pause the video, take you about 3-4 minutes, and then I'll show you the answers. All right, here's the answers. So the first one, right, we did together, but the second one, what is the molarity of 1 liter of Ki, or what molarity of 1 liter of Ki would you use to make 0.3 liters of 1.25 molar Ki? Well, M1 is our X, it's our variable. V1 is 1 liter, M2 is 1.25 molar, and V2 is 0.3 liters. So 1x equals 0.3 times 1.25. So x equals 0.3 times 1.25, and you get your answer right here. All right, so that's all we're doing today. Molarity and then some molarity volume diluting solution stuff. Now, we are going to go to OnCampus to see our homework. All right. Your homework is a little bit different this time. All right. So instead of a Google form or something like that, you're going to go to your assignments tab. All right. And for me, it's on future, but for you, it'll be current. You'll click on Unit 9.5 homework, and it's an assessment. All right, so it's an assessment sort of thing, which means you're going to go in there, and it's going to be OnCampus. All right, when you go OnCampus, it's going to be multiple choice questions. They're going to go in the gradebook right away, and you still get multiple tries. Or I think you get exactly 2 tries on this one. It's 2 or 3 questions. Just like the multiple choice answers, submit it. It'll give you what you got right and what you got wrong. It'll give you your score. And then you have 1 opportunity to redo it if you like. So this is only a couple more questions. It should take you somewhere in the ballpark of 10 to 15 minutes. All of these, chemistry classes are set up to take an hour or less for most students. So just take the time to get this practice work done. Submit it. It'll go in the gradebook once it's past the due date. And that's it for today. I'll see you on Friday.